Hey guys, welcome to your 6.1B notes, meaning day 2 of 6.1. Remember that yesterday we learned a couple things. Anything to the 0 power is 1, so it doesn't matter where it is, if it's a number or a variable, anything to the 0 power is 1. The other thing that we learned is that if it has a negative exponent, it needs to move position. So if it was on the top, it's going to move to the bottom of a fraction. If it was on the bottom of a fraction, it's going to move to the top. Okay, so that's what we learned yesterday. Today we're going to work more with these exponents and learn about other rules of exponents. So simplify, meaning no parentheses and all like bases have been combined. So how many 4s do you see here? I have 4 times 4 times 4. So to me that looks like I have 3 4s, which means I'm going to rewrite it as 4 to the 3rd power. And I'm going to use that up arrow in my calculator. Remember that's 4 and then that caret key and then 3. And I'm going to hit enter and I get 64. Okay, so there's my first one. My second one, how many n's do you see? I have 1, 2, 3, 4, 5 n's. So this looks like n to the 5th power, n 5 times. Okay. My last one, I have 2 2's to start with. Then it says I get 3 more. And then 3 more. So how many 2's do I have total? Okay, so I'm going to count them up. It looks to me like I have 8 2's, so 2 to the 8th, 2 8 times. And I'm going to type that in my calculator with that caret key, and I get 256. Okay, so today we are going to talk about simplification. You're going to use your calculator more, and then we are going to get into more rules of exponents. Okay, so this is all calculator work, so get your calculator ready. Okay, and I want you to type in with the parentheses exactly where I have them, -4 squared. So we're starting up here, -4 squared. We're typing it in our calculator. And we get a positive 16. Okay. My second one, I've got the negative on the outside, and then I have 4 inside my parentheses squared. And this one I get a negative 16. Okay, feel free to pause the video at any time if I'm going too fast, or skip ahead if I'm going too slow. But please make sure you check your work as you go. Okay, moving on, I have -3 to the 3rd power. This is a negative 27. Then I've got the negative on the outside to the 3rd power. It's also a negative 27. And then this last one, I have 2 negatives. So I have a negative on the outside and on the inside. And that's going to get me a positive 27. Okay, so we want to look at what happens when my base is negative. Okay, so if my base is negative and I have even exponents. So my base is negative and I have even exponents. That would be this first problem right here. We know that we should get a positive number. Okay, because that's saying like negative times a negative, which we know is positive. Okay, my second option is if I have a negative base, but I have an odd exponent. So that means the number that's the small one is odd, which would be this one down here. Okay, so that tells me that this should still be a negative number, because that's like a negative times a negative times a negative. Okay, 3 negatives, it's still negative. So that's going to give me a negative number. Okay, so here are some rules that we're going to work with today. Okay, the first one is the product of powers property. What this says is anytime my bases are the same, so that big number is the same, I can add my exponents together. Okay, so notice you don't see any parentheses. They have the same base. We add the exponents. So for my variables, it's just m plus n. When I actually have numbers, I'm adding that 6 plus the 3. So 6 plus 3 gets me 4 to the 9th. And I would go one step further, plug that in my calculator, and I get this super huge number. That's 262,144. Okay, we can also figure out what happens if we do have parentheses. So the first one we didn't have any parentheses. The second one we do. Okay, so notice that you only see the base one time. So my base is only on here one time. Okay, but we have different exponents happening. So it says a to the m to the nth. So what we do is we actually multiply our exponents. Okay. So power of a power, meaning I have two exponents with the same base. So I'm multiplying my exponents together. So in my numbers example, I have 6 times 3, which gets me 4 to the 18th. Okay, and again, you could type that in your calculator, 4 with that caret button, 18, and you would get a large number, a very large number. Okay. And the last thing we need to talk about is a power of a product. Okay, notice that you have two different bases inside this set of parentheses. So I have an A and a B. Okay, and notice what's happening to those. So each of them gets this exponent. It's kind of like distributing, but you're distributing an exponent. Okay, so here in the numbers problem, everything gets this exponent. Okay, every single thing. So that's why it's 2 times 3, or 2 to the third times 30. Then I have my 3 to the second times 3, x to the third, and y to the fifth times 3. Okay, so they keep their original number. Remember that the property right above it said that we multiply our exponents. So if there's already something there, we're multiplying. Okay, and then we just need to simplify. Okay, so everything gets multiplied together. That's this next step. Everything's multiplied together here. And then there's simplifying the numbers and multiplying those together. Okay. So let's try a few. So my first one, I have x to the third times x to the fifth times x to the fourth. Okay, so notice that these all have the same base. So here I have the same base. I have the x multiple times, so I know I'm going to be using that first property. I see my base multiple times, so I'm using this first property. And now I just have to count. Okay, we add all of our exponents together. But we don't want to forget that this x actually has an exponent of 1. So what this really looks like is x to the third plus 1 plus 5 plus 4. Okay, so what exponent goes up top? So add all of those numbers together. 3 plus 1 plus 5 plus 4. I get x to the 13th, and that's your answer. Okay, this next one, anytime that it's all numbers, you can plug it right into your calculator. So I'm plugging that right into my calculator, negative 5 to the third power, and I get negative 125. That's my answer. Okay, and this last one, I have parentheses. Okay, so I know that all of these bases, I've got two different bases here, an h and a t. they're all getting that power of 3. So I have h to the 3rd power and t to the 12th power. Okay, now some of you are probably like, Miss Sanders, how did you get 12? Well, 12 came from multiplication. Okay, so I'm going to break that down. We have t to the 4 times 3 power. We're multiplying those together because t already had a 4. It gets the 3. So that is h to the 3rd power, t to the 12th. Okay, here's one with a few more pieces to it. So I know that this whole first set has an exponent of 3. So this is very similar to what we just did. Everything in here gets that power of 3. Okay, so notice there's 3 bases. There's 3 bases in there. So I get 9 to the 3rd power, a to the 3rd power. B already had a 2nd power, but we need to multiply that times 3. Okay, so there's the first part. Here comes the second part. So second set of parentheses has a 2 on the outside. Again, I have 3 different bases. So now I have a -2 squared times a already had a 3rd power, so it gets that times 2. B already had a 3rd power, it gets that times 2. Okay, now we need to simplify. So the first thing that we're going to do is look and see if I can simplify any more exponents. Okay, so 9 to the 3rd, that's done. A to the 3rd, that's done. But right here I can do 2 times 3. So I have b to the 6th. Then I can't simplify my next exponent. But here we go, 3 times 2, that's a to the 6th. And again, 3 times 2, that's b to the 6th. Okay, now what we need to do is actually look and see, do I have any common bases? Okay, do I have any common bases? So it looks like I have an a from my first set, and I also have an a from my second set. Okay, so I have 3 in my first set, 6 in my second set. So I'm going to add those exponents together, and I have 9 of those total. Okay, then I've got b. So I've got a b to the 6th and a b to the 6th. So that's saying I have 6 b's. So b 6 times, and then b 6 more times. So I have b 12 times. Okay, so remember that's just like b repeatedly, okay, 12 times. Okay, so just b until you all get it all the way up to 12. Okay. The other thing that I have are these numbers, so I'm going to bring that down. I have 9 to the 3rd, and I have -2 squared. Okay, remember, numbers are things you can put in your calculator. So I'm going to do 9 to the 3rd power in my calculator, and I get 729. Then I'm going to do my -2 to the 2nd power in my calculator, and I get a +4. Please remember your parentheses. Okay, and now I know I can actually multiply numbers together, so 729 times 4 gets me 2,916, and I just bring my a over and my b over. So here's my final answer, 2,916, a to the 9th, b to the 12th. Okay, last one, we're going to do the same thing. So this first one, it's like having a 1 exponent out here. So everything is just being multiplied by the exponent of 1. So 2 to the 1st, x times x to the 2nd times 1, and y to the 1st. Okay, now that doesn't actually change anything. So if you knew that already, that's great. Okay, it just looks like this, 2x squared y. But my second set does change because I have a number out there. So right here I have x to the 3rd times 2 and y to the 4th times 2. Okay, now I'm going to multiply those together. So I have x to the 6th y to the 8th. Okay. Now I'm switching back. I'm done with parentheses, so no more multiplying